oranges, you are given an m times n grade where each cell can have one of the three values: 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is for direction or adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until this no cell has a fresh orange. If this is impossible, return -1. So, for example, here it's illustrated that this is the only one here, shown over here too, that is rotten. So we move to the next minute, and we can only go left, right, up, and down in the forward direction. So these are the ones in the next minute that have been spoiled, and so in the next minute we can go up and down in these ones, and up until this minute 4, and we get 4 output. Here we can't get it, so we get -1, and here we have 0 because since there are no fresh oranges at minute 1, and the answer is just minute 1. So let's copy and paste this to keep this in mind. So we use a BFS but first search for this traversal for this problem because we need to spread because of the nature of the problem, and the rotten oranges. So now we have this. Let's make our let's initialize our row and column variables. Let's just name them R and C to make it short. R and C. So let's name R equals to RC equals to the len. So R will be the len of grade, and C will be, the column will be the len of grade. Index 0. So basically this means that this will be how much rows we have. So 1, 2, 3. So 1, 2, 3 over here, and this will be based on the first the column of how much number values do you have. So this 1, 2, 3. So these are the columns: 1, 2, 3, 1, 2, 3. This is how we get this number. So let's initialize our fresh fruit. Fresh equals to oranges. Initialize. Oops. Comment this out. Fresh oranges to 0. 0, 0, because we are about we will subtract them later. Kill. Let's kill define name our kill. Establish our kill used, that is used for BFS traversals. So kill will be equals to DQ. So now let's see how we're going to do this. So for every I, so let's add every value from this inside our queues. So let's do so for I in the range of C, no, sorry, R, or column, I mean row. So for every row, let's go to every column and then move on to the next row. So for J in the range of C, so let's name for every column, I mean every row, oops, for every row, let's add every column, let's go through every column, then move to the next row, one by one. For every column, move on to, let's move on to every row one by one, then move on to the next one. So now we have this and this. Let's check if the row is spoiled. So if grade, hold on, grade is equals to grade J is equals to 2, which is what's spoiled as shown over here, rotten orange. Let's add them. Q dot append the I and the J. So basically, this will allow us to go through every column. So whichever ones are spoiled, that's what we're going to add inside. Else, or if hold on, grade I J is equals to 1. Grade I J. So if every I is equals to 1, oops, this is the wrong answer. So it should be fresh oranges plus 1. As you can see over here, that's the fresh orange. So we add them, we add 1 to it. So adding rotten oranges to our kill. And counting fresh ones. So we have this and this and this. And now let's initialize our minutes passed. So minutes passed will be equals to 0. So where we have any minutes passed equals 0. So now let's pop the values from our queue. So that will be, so while we have a queue, so this is basically our starting zeros from over here. So while we have a queue, minutes passed. So now let's add when. Minutes passed. Oops. First equals to 1. We add 1 and then put, so for every orange and inside our queue, the range of the len of queue, we can just put size, it doesn't matter. I'll just put size with this. Size and size is equals to so for every, let's pop it. Q, no. Let's name them x and y. X and y equals to pop. No, q dot pop left. Parentheses. So for every value inside it, we have to pop it. So now let's check. I forgot to make our directions. Directions list will be x will be list, and then so in this order, this one will be this. So the first number here will be our. So this one over here, 0. This one over here means up. So that will take us 1 up. And this one will take us -1, 0, 1 down. So just know that. So if we add a row down, this will be, it will be going down 1. So that's why it is that. And if you do, hold on. This one over here, 1 will take us. No. This one is down. This one is down, and this one is up. This one is down. This one is up. So down 1 will be adding 1, just to remember, and this -1 on the x-axis will take us up. That's basically it. I was just a little bit confused. So left, this one is easy. It's not opposites like how we used to do, seeing them. So this is left, and this is right. So minus 1 written in order up, no, down. I was confused again. Up, left, and right. So now that's it. Basically that for that. So for dx, so that will be the x value, the direction x, and for direction x dy, and directions in our directions list. Let's make let's call them nx and ny equals to x plus x plus, hold on, dx, so the direction, and then ny will be y plus dy. So that's basically it for this reduction. So now let's check if we're within bounds. Let's check if we are within bounds and if our current grade is fresh orange to then make rotten. Iterate to bear give check every direction of the current popped orange. For directional wait. So how, let's check. So if, let's call it c, 0 is it has to be greater than or equals to 0, or and then make it less than, oops, less than the row, and let's call it nx. Yeah, it's nx, and it also has to be a positive number. I mean, within the bounds of our columns, so that will be 0 less than or equals to ny, and less than our column c. It's just c, just c. So basically this is 0. We check this, and then this. So this means that our nx has to be more than 0. And then so this is basically checking the row aspect of it, and this one is checking the columns. So it has to be within bounds. So this means it has to be from, it can't be less than this, nor can it be greater than uh, our rows, and so this means it can't be greater than, it has to be within this, and this means it has to be within, wait, well, no, this means that it has to be no, row means that it has to be within this value, so from here to here, and the column is basically this way, so the column is that way. That's basically what it means. And this one, and grade is, hold on, an x and y. It will be, let's check, if it's equals to 1. So fresh is 1. Let's make grade and yx equals to ny equals to 2. We will spoil the run, the fresh food orange. And then now let's hold on. So once we do this, we'll then call fresh oranges. So we take fresh oranges, and then -1 equals to -1. So we take it from this. That's been added. Hold on. Where did we add it? So once we add all of these inside, so we have to take this and add it. So now let's take the value nx and ny and append them to our queue for the next values. So we can check for the next. So nq append tuple nx and y. Boom, and that's basically it. Hopefully, think so. So let's check if fresh oranges. So if we no longer have fresh oranges, let's is equals to 0. Return minutes passed. And then this, return this. So basically, if we can't find a fresh orange, return -1. This should work well. Hopefully, let's see. Is there any syntax errors? Well, pop left. Okay, let's see. Minutes pass. It's not defined. And it says we've been able to pass 2 out of what cases? 2 out of 3 cases. There's 1 case missing. Oh, that's 0 here. So basically, hold on. Oh yes. So this we forgot to take care of this edge cases. I mean, I forgot to take care of this edge. So that, so if we fresh fruit, fresh oranges are 0, then just return 0. It's an edge case. So let's call it, so if fresh oranges is equals to 0, return 0. So let me copy and paste this, boom, to this part over here, move it here. So once we count it all here, and that should be it. Let's see, and boom, it's been able to pass all, our 3 cases. So our time and space complexities are time complexity of m times n for m times n, and also space complexity is O of m times n for grid and kill, and for rows and columns. Boom, and let's submit it to see if it's going to pass all cases. And it's been able to pass all cases. It says runtime 32%. Last time I did it said 92%. So this isn't too accurate, but that's our time complexity. It's not one of the best, but it is the most optimized one that we have for this problem. And that's it for this problem.